Alright, we're going to go on to problems 2a and b. Both of these are based around thermodynamics, so we're going to first consider our equations above. A lot of equations for you to memorize in this chapter. Don't be discouraged, it's honestly just algebra. Plug and chug and get your answers. Alright, so for 2a, we want to consider the reaction of A being converted into B at 25 degrees Celsius. If the delta G of this reaction is positive 0.5 kilocalories per mole, the K equilibrium is blank and the percent conversion is blank. And then 2b is the same thing, but we have a negative delta G instead of a positive delta G. So it's the same concept, so we can do them both together. And by using this top equation over here, which compares K equilibrium to our Gibbs free energy. K equilibrium is the tendency for a reaction to go to completion. So if it's a big number, it means that you're going to get a lot of the product. If it's a number less than 1, you're getting just a lot of reactant. It's not favorable. It's not going to completion or to the product side. It's going to the reactant side if it's less than 1. Gibbs free energy is the energy available to work. It's the energy of the system. And the rest is just temperature and some constants. E is the natural log. It's a number we find a lot in nature, and R is just a constant number. We have to be careful with it because we have 2 values for it. And since in this case we're dealing with kilocalories, as seen down here, we actually have to use a third number. We have to convert calories to kilocalories. So let's do that first. Looking at our kilocalorie, let's take that down here. Okay, so going to go to calories, which is a bigger number, we have to make this number smaller. It's a kilo, so a thousandth place, so we can move over the decimal 3 times. So we really have to use 0.01987, and that will be our actual constant in this case. Okay, so now let's just go straight to plug and chug. Let's take this equation up here that we need to use to solve our K equilibrium. Okay, so let's see what we have in the problem. We have delta G at temperature. If you see delta G with the degree sign, that means it's always taking place at 25 degrees Celsius. Make sure we convert that, since we need to know the temperature. Temperature is always in kelvins, so it's really, to convert to kelvins, you add degrees Celsius to 273. So our true degrees are 298 degrees Kelvin. Alright, so let's plug all that in. K equilibrium is the same thing as E raised to the negative. Make sure you watch your negative. Since our delta G was positive, we plug it in here and keep the negative sign, because a negative times a positive is a negative. So in this case, you actually get the negative number. So it's negative 0.5 from our problem. R is the number we calculated. We had to convert. That was a very small decimal, 0.00198. I'll round that to 0.002. And our temperature was, the Kelvin we calculated, 298. Now you plug that into your calculator. I usually get something about 0.45. Sometimes I get 0.43. But the point is, it's the closest to B, which is our answer. Now, the second number, even though we could stop here, we calculate, if we wanted to calculate that, we would use our K equilibrium definition, which is KEQ equals products over reactants. The book gives a nice table and it doesn't really teach you how to solve for this number, but we can do this by using an identity. If you have two products, you can use the algebraic equation products equals 100 minus x over x. That's because you have two things and you know they add up to 100%. So really it would be, since we know we have A and B in this problem, we know their percents and they're going to add up to 100. If we substituted this, they add up to equal 100. If you did a couple algebraic manipulations, you can substitute them for each other and get 100 minus x over x. If you really wanted to solve for this, we would plug in our k-equilibrium that we just solved for with our equation. So let's make room for this new equation. And I'll copy and paste that down here. Okay. So we know our k-equilibrium from our math we just did is 0.45, saying that equal to 100 over x over x. Okay. So to solve for what we want, we actually want to know this value up top, because we want to know the product value, how much is set to completion. So when we solve for x, we have to put it back into and solve for 100 minus x. So let's see, we multiply across, multiply x by this side, x by this side, we get 0.45x, 0.45x equals 100 minus x. Now we can put our x's together and we get 1.45x equals 100. That's just from adding x to both sides. X minus x would give us 0, and plus x is 1x plus 0.45. Now we can solve for that x. X is equal to 100 divided by 1.45, which will give us about, I believe, 69. And remember, this is not the value we want the product. So if we looked at it, it was k-equilibrium equals products over reactant. We want to know the ones that became product. So we have to plug that number back into 100 minus x. So 100, what we really want is 100 minus this number, so 29 or 69, and that would give us about 31%. Since 100 was in percent at the beginning. So we have 2a giving us the exact same answer as we found in the front, confirming that that's the second case. Now we want to move on to problem 2b. Let's clean up a little. And again, we're going to be doing the exact same thing, except with just slightly different numbers. So let's move on. We have 0, 2 here. Okay, so the only difference is we're switching signs. As we said, that one was negative, one was positive. This time we have a negative being plugged into negative delta g. Negative times a negative is a positive, so we can get rid this time of this negative number. If you plug that into your calculator, let me calculate that real quick. And sorry if you can't see. We end up with it equaling about 2.2. Again, your numbers may be a little off, but that's okay. You just round to the closest one. And that matches D, which will be our answer in this case. If you want to again match the percentage as before, all you have to do is plug again that the first value that we just solved for into this equation. And again, we care about the 100 minus x part because we want to know what became the product. So we would plug 2.2 equals 100 minus x over x. Move the x over, 2.2x equals 100 minus x. Add x to both sides, and you would have 3.2x equals 100. Then you would divide 3.2 by both sides, and x would be about 31. 100 minus 31 is what we like, is what our percent conversion actually is. So we end up with about 69%.